So I think where I would start is really around the pace of change. So, I think data centers are obviously an immensely interesting area right now because the whole architecture for how power is moved around these facilities, the way that we're building these facilities, the roles of different stakeholders are all changing in real time. And so I think what I would really advise folks to do is embrace that pace of change and try to learn the basics and the fundamentals of who does what and how they do their work and how we build things, but be wary of reaching conclusions that the way we've always done things in the past is the way that we'll always do things in the future. This is a highly dynamic, highly flexible, and bespoke industry where there's a lot of different ways of doing things. And so I think there's enormous opportunities in both technical fields of designing the innovations and technologies that will ultimately underpin power and cooling and data transportation in data centers. But then there's also a whole other field of folks that are pulling the capital together to actually build these massive mega projects that are extremely exciting at this point. This is Tim Heidel, co-founder and CEO at VEIR, and you're watching the Data Center Go-to-Market podcast.
Hi, it's Joshua Feinberg from the Data Center Go-to-Market podcast, and I'm thrilled to be welcoming a very special guest today. Joining me today is Tim Heidel, who is co-founder and CEO of VEIR, based in Massachusetts. Tim, welcome to the podcast.
Excited to be here. Looking forward to this conversation.
Excited for you to be here as well. You're in a really unique category. I talk to people in various kinds of energy and power, both incumbents and startups, but you're building superconducting power solutions to carry more energy across transmission lines and throughout data centers. And what's especially interesting about that is in the last 2-3 years, Sam Altman, Jensen Huang have kind of become celebrities in this space because of the density growth and the power requirements that are now coming in data centers. But you had the foresight to start up VEIR back in 2019. Can you kind of take us through what led you to realize that there was a need in the marketplace for this?
Yeah, of course. So I think what we realized as we were getting ready to launch the company is for a whole bunch of different reasons, we need to build a lot more electrical infrastructure in the next couple of decades, right? So I've spent a lot of my career in the climate area, and a lot of the studies that have been published around the world for how to best and most cost effectively decarbonize the entire world economy, you need to double and triple the scale of transmission networks around the world. But transmission is really hard to build. It takes a really long time. And so we saw the challenge of building dense power infrastructure, putting a lot of power into smaller right of ways, and decided that we were really excited about the potential for using high temperature superconductors. In case your audience isn't familiar with these materials, this is a special class of materials that's been in development for decades, where under certain operating conditions, the material no longer has resistance. And so you can actually transmit an enormous amount of electrical current through the material and not generate a ton of heat. So you can build really high capacity cables and conductors. And while people have been developing superconducting transmission solutions for 25 years, they just have never been designed in a way that achieves the scalability, reliability, and cost that's needed for ubiquitous applications. And we felt we had a really unique opportunity to do that around a couple of new technical approaches. So we started life focusing on transmission. And then along the way, over the last couple of years, as the power density demands and as the urgency of solving some of the really hardest power delivery problems on the face of the planet today started to show up in data centers, we started to really focus very heavily on the data center market as our go-to-market strategy for how to get to scale with superconducting power delivery solutions. We're very fortunate that the core foundational technology that's required to be able to use superconductors to get to really high power density inside of data centers is very, very close to what we had been developing originally for higher voltage outdoor transmission applications.
So that makes a ton of sense. So the origin with this is even before people realized how much power was going to be needed for these 600 kilowatt GPU centric racks. You were thinking about that the grid in the US is starting to face massive strain. You think about that big snowstorm in Texas years ago, and you see various presidents getting up and talking about how our infrastructure is lagging behind other countries. So this was originally based on the utility grid just not being able to conduct enough power for demands even before GPUs enter the equation.
Exactly. And in fact, the way that we got pulled into data centers was, we had been developing our transmission solutions and we're talking to a lot of utilities and a lot of different classes of commercial customers and new generation developers. And then we had started to strike up conversations with data center developers, initially with a focus on how do we solve the transmission problems that prevent them from interconnecting to the grid quickly. And in some cases, how do we solve the last mile transmission or distribution problem, getting the power from the existing power grid substation to their data center campus? And that was the original conversations that we were starting to build relationships with the data center community. And then some of those customers turned around and pulled us into these really hard problems they were starting to see on the horizon on how do you deliver power to server racks that are consuming hundreds of kilowatts and then ultimately multiple megawatts, and how do we efficiently build some of the very largest facilities that have ever been contemplated to be able to keep up with the demands on the AI side. And so we sort of got pulled into this a couple of years ago and have now really started to focus on that in the last couple of years.
So is this something that you always thought about back when you were in high school, when you were in college, undergrad, about these kinds of problems, or was there some milestones, some projects that you worked on early on in your career that shaped your vision for what this might look like?
Yeah, so I've always been focused on energy my whole career. And early in my career, I had the opportunity to serve as the research director for MIT's Future of the Electric Grid study that we published back in 2011. And that gave me an opportunity, really at the earliest portion of my career, to interview stakeholders throughout the entirety of the energy system and understand challenges and opportunities in electricity systems, and looking out multiple decades and seeing the need for new capacity. I then was fortunate to be able to go to ARPA-E at the Department of Energy, where we funded early stage, high risk, high reward energy technology research. And again, there I focused on power system technologies, both hardware and software, as well as power electronics. All with an idea to how do we build technologies that enable us to get the most out of our electricity systems, scale them very quickly, and utilize power electronics. And so it's really fortunate that provided a foundation. I've been focused on how do we build better and bigger transmission systems for a really long time now.
So 15 years ago, when you were first really pivoting into this, what was the driving sentiment that was pushing a lot of these initiatives? Was it sustainability? Was it aging grid? Was it concern about physical terrorism, cyber attacks? What originally motivated a lot of this?
All of the above. I mean, I think the changing generation mix associated with the widespread adoption of low cost renewables was certainly a big driving factor. But electricity system growth also underpins the resilience of entire economies. Electricity system expansion allows for the expansion and modernization of economies. It allows for the reliability that we all enjoy every day, right? And we've seen massive events around the importance of resiliency. We were focusing on as well on threats related to cybersecurity and physical security as well. And those threats, one of the ways that you mitigate them is through having additional capacity, additional redundancy in the system, additional connections. And so it's always been motivated by an enormous number of different factors.
So, Tim, given that you spent quite a bit of your professional career both on the commercial side and in a research setting, I imagine from time to time you come across students and colleagues that are much earlier on in their career. When you're having these conversations with, especially like teens or even kids that are even before that in elementary school, middle school, and high school, and they're starting to think about careers, what advice would you give to someone that's heard about data centers, that's heard about critical infrastructure? They don't seem overly technical. They seem like they're really good soft skills, really good communicator, kind of person that would like run for president of their class. What would you talk about with a niece, nephew, uh, or neighbor's kid that's curious to pick your brains over coffee about what they should be thinking about with career opportunities?
Yeah. So I think that where I would start is really around the pace of change. So, I think data centers are obviously an immensely interesting area right now because the whole architecture for how power is moved around these facilities, the way that we're building these facilities, the roles of different stakeholders are all changing in real time. And so I think what I would really advise folks to do is embrace that pace of change and try to learn the basics and the fundamentals of who does what and how they do their work and how we build things, but be wary of reaching conclusions that the way we've always done things in the past is the way that we'll always do things in the future. This is a highly dynamic, highly flexible, and bespoke industry where there's a lot of different ways of doing things. And so I think there's enormous opportunities in both technical fields of designing the innovations and technologies that will ultimately underpin power and cooling and data transportation in data centers. But then there's also a whole other field of folks that are pulling the capital together to actually build these massive mega projects that are extremely exciting at this point. There's a lot of policy questions of interest as well. Like there's a ton of different threads that folks can pull, all with an eye towards, how do we build unprecedented density and scale within the industry.
The Data Center Go-to-Market podcast is sponsored by DCSMI, elevating the role of sales, marketing, and go-to-market GTM professionals in the growth of the data center industry. To stay informed about upcoming episodes, make sure that you subscribe to the Data Center Sales and Marketing newsletter on the DCSMI website that can be found at www.dcsmi.com. Again, that URL is www.dcsmi.com.
So when you think about your own team, you're at a startup stage with VEIR, like what do you see as right now some of the big commercial challenges? What do you envision being some of the big commercial challenges where you think talent that's relatively early on in their career would make a big impact?
Yeah. So I think reliability and safety are critical to all large scale infrastructures. And this is important in the industry that we started in transmission. It's important in the data center community as well. And so, and it takes a real specialty to be able to think through complex systems and all of the different interacting pieces of these very large infrastructures and be able to peer around corners and see, what could the daisy chain of safety issues or reliability issues be? How do things interact with other pieces and parts? And be able to engineer the highest reliability and the highest safety equipment. And I think that the folks that we have on our team that we're really, really excited about are those folks that have some systems engineering background or have built very complex systems, and they've got this inherent ability to sort of study the reliability impacts, the safety impacts of different design decisions that we're making in our solutions. And so I think that's the systems engineering, the complex systems arena, the folks who really learn how different pieces of systems interact with each other and define interfaces. The data center environment in particular, there's a ton of different people. There's a ton of different organizations and there's lots of technology, right? And so everybody has to interface with everybody else. And this has never been more true than right now because we're talking about entirely new power infrastructures. We're talking about the shift to DC. We're talking about cooling infrastructure. And so everybody has expertise in a set of components, but nobody has expertise in everything. So to be successful, you have to be able to, be an expert in your domain, but then also be able to interface really effectively and communicate really effectively with all the other partners around the table that ultimately you have to interface with and work with well to bring a full solution to market.
So many in this industry are focusing on talent shortages, are focusing on that we have millions of baby boomers going to be retiring in the near future. But it sounds like a lot of where you see the biggest opportunity is influencing like the deans of big engineering colleges to think about the curriculum that they utilize and the courses and the experiential learning that students go through undergrad, grad kind of setting to understand the ecosystem better.
Yeah, I mean, I think there's a lot of opportunities with both new and more junior engineering talent, but I think there's also a lot of new opportunities for folks that have a lot more experience in their careers. And the world is changing very quickly right now, and so folks that show the flexibility to adapt new tools, new processes, that are willing to part ways with the classical rules of thumb of how you've always done something for 40 years, also have an enormous opportunity.
Yeah, that's the next question I usually talk with people about on this podcast is you have someone that you work with maybe 10 or 15 years ago, you haven't seen them in a while, you run into them at a conference or the airport, they're probably a little more on the soft skills, project management, administrative kind of side, maybe running an office or entity when you're back at MIT, and you sense they're a little bit burned out, and they're really curious to get some feedback from you on what they can do to re-energize their career, given that they're mid-career and not looking to retire anytime soon.
I mean, this is an immensely exciting time to be in this industry. I mean, you know, the just about everything in terms of how we build, plan, construct, engineer, invest in data centers have all been upended in the last couple of years because of the pace of growth, right? And I think that folks who have been in and around this industry for a very long time may have a perspective on, well, we've always done energy in one way, right? Or we've always used the following approach to moving power from point A to point B on a data center campus or inside, right? Or it could be in adjacent technologies like cooling or data. And the technical capacity of what we're able to offer today is changing so quickly because of the urgency of these challenges. And so I think there's enormous opportunity for folks to, you know, identify some of their underlying rules of thumb and some of the ways that they've always thought about solving particular problems and saying, hey, this is an opportunity where we actually could go back to a clean sheet and say, is there a better way? There's no absolute requirement to stick with the way that you were doing something 5 or 10 years ago. You know, in an industry that is operating very successfully with high levels of reliability and high levels of safety and not a lot of growth, you don't often have the opportunity to truly embrace disruptive change. And the environment that we're in now has so much growth, so much urgency, so much desire for speed that it is an opportunity where there is this unique opportunity to look at and evaluate and adopt disruptive technologies in a way that really, you know, hasn't necessarily always existed. So I'd share that perspective with folks and really say, look, use this as an opportunity to identify and go work on step change technologies in a way that may not be possible all the time.
There's an interesting change that's been going on at the same time as well over the past 5 or 10 years, and this was accelerated during the early 2020s, where more and more highly technical buyers, very likely your addressable market, your ideal clients, your prioritized buyer personas, don't want to spend a lot of time with sales teams anymore. But they are very comfortable spending time with peers. So we're increasingly seeing companies like yours that are hiring engineers into roles that were traditionally seen as less technical sales roles, and the same thing on the data center operator side and the tech side is they're hiring IT professionals that are seen more as peers. Is that something that you've seen to be a factor among the talent that you recruit for VEIR?
Yeah, so I think the underlying philosophy there is our approach to finding ubiquitous adoption for data center power solutions that we're building is through partnerships. And it's not really, it doesn't look like a traditional sales cycle of I have a widget, I want to convince you to buy my widget. It's much more of, hey, let's work together on a reference design and let's imagine the art of the possible of what this opens up in terms of your facility design, your layout, right? So we built cables using superconductors that can fit 10 times more power in the same exact space and can carry power efficiently over longer distances with less voltage drop. And so when you have that type of capability, not only can you deploy projects faster in some cases, but you can also redesign the layout of your building. You can fit more server racks or more GPUs into a much smaller space. But fully realizing that opportunity requires both our solutions for power, but you also have to come up with a solution for data and a solution for cooling. And so there's a lot of sort of peer-to-peer partnership and brainstorming that we have to do with technical colleagues in other companies who understand the nuance of how do you protect electrical systems, where do you put your conversion. We don't do power conversion, but a lot of folks are talking about DC architectures today, and so now we all need AC to DC converters. There's options to put those right at the AI pod. There's options to put those farther away. Our solution works in both cases, right? But the nature of how we design it, whether it's going to operate at 800 volts DC, or it's going to operate in a more traditional AC environment are slightly different. And so there's a lot of that sort of co-partnering that works. And so back to your question, I mean, I think that means that there's a higher bar for having technical expertise and the ability to brainstorm across our entire team. And if you look at the folks that are leading some of our efforts on business development and partnerships, most of them are technical. Most of them have some experience in data centers or adjacent fields, and so can really sit there and really understand the questions that we're getting from a lot of the partners and customers we're interacting with.
What do you think's the biggest mistake or oversight that people are making when they look at your category of how to improve the power density?
I think it's not realizing the pace of change and speaking in different contexts. I think this world is changing so quickly. A couple of years ago, server racks in data centers were consuming, 10 or 20 kilowatts, and now we're talking about several hundred kilowatts. Year or 2 years from now, we're going to be at 600, 800 kilowatts, and then we're going to move right on to megawatt. And I think one of the challenges we've seen, and one of the mistakes that we've seen folks make, is not being clear on what context they're talking about, right? There are challenges that folks need to be solving today based on the server racks that they're deploying today at less than 100 kilowatts. There's other folks that are deeply focused on, how do I design that project that I'm going to go deploy in 18 to 24 months that's using a much higher power server rack, and therefore it needs to make different architectural decisions related to how we would move power around those facilities. And then there are still others that are entirely ensconced in the world of, we need to figure out how do we move power around when we've got 2 or 4 megawatt server racks. And if you're not really careful to talk about what's the time scale that we're talking about, what's the context in which we're talking, there's a mistake you can get into of where folks start to talk past each other, right? The solutions that we're going to be providing to enable 25 megawatt pods, 4 megawatt server racks are necessarily different and overkill in a world of the data centers that you're deploying right now today in 2025 and into early 2026. And so, every once in a while we'll run into a case where we're describing something about our product roadmap or what we think is possible, and we'll see folks that are a bit deer in the headlights of, I don't understand why that would be needed or how that would be used. And more often than not, it's because that we're thinking about different time contexts, or we're thinking about different deployment contexts as well. Of course, there's also a huge diversity of different types of data centers that are used for different purposes, and some of them really want to go after the very highest performance and the highest density. That's where we shine the best. There's others that are doing more conventional non-AI applications where the business case for a superconducting solution may not be there today.
So it's really interesting that a lot of the alignment isn't just understanding their context of where they are in the ecosystem, but understanding the time horizon that they're planning for.
Precisely right.
Got it. Final area I want to ask you about today is, when you look into your crystal ball with a 2 to 4 year time horizon, how do you think leading a company like VEIR is going to change, and what do you think would stay the same?
Yeah, so I mean, the startup journey is really exciting, right? Because you transit through all these different levels of maturity. So today we're focused on building demonstrations of our first generation products and focusing on lining up pilots to deploy with key partners to demonstrate the full capacity of what we can do with our cables, right? 3 megawatts in a single cable. And what does that look like? And how does it interact with the pods? Next year, we're going to be focused on building out and qualifying our manufacturing facilities and really firming up all the resiliency within our supply chain and getting ready to start doing commercial deliveries. That requires us to build a project execution team that will work side by side with the folks that are going to go out and implement all of our technologies. You look forward 2 or 4 years, and we expect to be in commercial projects that we're delivering into mega scale campuses and starting to grow the overall volume of our deliveries. And so, I think it's super exciting to be in an environment where, what you're working on and what you're focusing on every day is changing so quickly. And the core competencies you need is obviously changing so quickly as well. And it's amazing every day to see our team maturing in real time and learning in real time and being capable of doing things today that they could not possibly have thought about doing 2 years ago. And I expect to see a lot of that same transformation in the next 2 years.
They're growing with you.
Exactly right.
Cool. Tim, I really appreciate you taking the time today to talk with me about what you're working on with VEIR, the advice that you'd give to people at various stages of your career, what's been working well so far for you in building bridges within the ecosystem, where you see some of the challenges are and how you're navigating around those challenges. If someone wants to follow what you're working on or reach out to you or learn more about VEIR, is LinkedIn a good place to start?
It absolutely is. That's probably the best place to find us.
Okay, cool. I'll make sure to include links to your profile and your company page and your website when we put together the show notes for this episode. But this has been really, really fascinating. You're in a very unique category. Obviously, a lot of interesting conversations across the industry about energy and power. But yeah, VEIR definitely has a very different approach to all this. I've been speaking today with Tim Heidel, who's CEO and founder of VEIR based in Massachusetts. Thanks so much for joining me today, Tim.
Thanks so much. Enjoyed the conversation.
Likewise.
The Data Center Go-to-Market podcast is sponsored by DCSMI, elevating the role of sales, marketing, and go-to-market GTM professionals in the growth of the data center industry. To stay informed about upcoming episodes, make sure that you subscribe to the Data Center Sales and Marketing newsletter on the DCSMI website that can be found at www.dcsmi.com. Again, that URL is www.dcsmi.com.